Okay, maybe we will be able to complete this chapter on erratics and mammoths. We have talked about a lot of concepts, by the way, and it's not easy. Don't feel bad if you feel confused or feel like you don't understand everything. Just leave it here, listen to it again if you want, ask questions, and keep moving forward with whatever little you can understand. Hopefully you understand a lot depending on how old you are. So we were talking about this relation between temperature and CO2. We said when things get colder and glaciers begin to build, we have the ice albedo feedback. Remember, it makes it colder and colder, and when it gets warmer and glaciers begin to melt, ice albedo feedback again happens, and more glaciers melt. But along the way, CO2 also begins to get trapped and buried when the glaciers grow, which means CO2 in the air drops, which means greenhouse gases decrease, which means temperature gets even colder. So it's not just ice albedo feedback. With that comes the temperature effect and the CO2 effect. So we should be able to see this in a graph. You are saying, show me the graph, don't talk so much. And right at the end of the last 2 centuries now, we will see what is happening compared to 800,000 years before. So the dips in the graph we are looking at here, that I'll explain in a minute, are the ice ages where the temperatures dropped and CO2 dropped. The peaks are the warmer periods in between. So we can think again that we are in an ice age because there is glacier on Greenland and glacier in Antarctica, glaciers in Himalaya and glaciers in the Andes and Alps and so on and so forth. Hence we are in a warmer part of an ice age, let's say. Not everybody agrees on these definitions, but we don't have to worry about it. And let's say there were much colder times of the ice ages like we had before 10,000 years ago, right? So that's what we are looking at here. So we are looking at CO2 going from less than 200 ppm in the atmosphere 800,000 years ago. As we go forward in time, we are here now over 400, and you can see that there is an increasing CO2, and if you are old enough you may see that this goes up very sharply and this comes down to again below 200, and it's going a little bit slower, and then it has all kinds of ups and downs. If you don't understand the details, don't worry. The main thing you want to understand is that CO2 goes up and then it goes down, it goes up and then it goes down, and then after industrial revolution, boom, it's gone up and up and up, and more than anything we have seen in this 800,000 year record of ice core derived estimated CO2 levels. What's happening to the temperature from the same ice core using our detective work with the oxygen isotopes? We can say temperatures in Antarctica were colder when it was at the bottom with the low CO2 in the air. Then it warms rapidly and then it cools again. It warms and it cools and so on. But what happened here? We haven't warmed. Even though CO2 went up, CO2 went up in the past, it warmed, and CO2 went down in the past, it cooled, and now CO2 has gone up through the roof, and then boom, we keep talking about global warming, but where is the warming? Well, folks, kids, children, you have learned this already. In the past, remember, there were no human beings running around here like us doing agriculture and so on. So this was happening, warming and cooling, because of what? You already learned that, because the orbit was changing either in its ellipticity or circularity, the tilt was changing, the precession was changing, the energy coming in or the distribution of energy was changing. So internal feedbacks, or once you change the energy and either start building glaciers or start melting glaciers, you had the ice albedo feedback, the CO2 feedback that was going to take it in that direction, and then orbit changed again and we came back. So there was a nice relation all along between CO2 increasing and decreasing and temperature increasing and decreasing, because orbits were providing the trigger for starting the glaciation or the deglaciation. What are we doing now? The orbit is not changing so much at all in this short time, or 10,000 years that we have been doing agriculture. It does change, it has some impact, but the main impact here is that we are taking out fossil fuels from under the ground, coal, petrol, gas, and so on. And of course we are also doing some deforestation and so on. So we are increasing CO2, but it's still a very short time, so the response has not started yet, even though it's warmed 1.3, 1.4 degrees since the beginning of the Industrial Revolution. It has not warmed as fast as it could if we continue to increase the CO2. Even if we stopped increasing CO2 here miraculously, magically, mysteriously, the warming will continue, because this is what the earth does. If you give it CO2, it'll put it in the ocean, it'll go into vegetation, some will remain in the atmosphere, and it'll continue to warm for a long time. Why? Remember, CO2 is inert gas. It doesn't react very well with anybody else other than dissolving in the water, and it stays around for centuries. The CO2 molecules in the air are accumulating since the Industrial Revolution. Think of a bucket, think of a tap. You open the tap and you start collecting the water in the bucket. The water in the bucket keeps staying there because there is no tap that is taking the water out of the bucket. So soon the bucket will get full. So the past relations took time to happen, and we are now waiting for the CO2 impact to continue. This is the story, again a bit complicated, don't worry about it. So let's move on and think about the fingerprints of CO2. People sometimes ask, which came first, the chicken or the egg? This is a serious question, and it's a biological question, it's an evolution question, and so on. So if we have temperature increasing and CO2 going up and down like this, what comes first? Here, the temperature change come first or the CO2 change first? We can use simple methods, again detective work, mathematics and statistics and so on, and we can show that here the temperature always begins to change first, and then CO2 begins to change after a few thousand years. And here we have changed CO2 first, so temperature is not changing like this yet, but it takes time. That's the point, right? So what a silly question. You think, which came first, chicken or the egg? It was the egg, of course. Dinosaurs were already laying eggs back in the days before there were any chickens around. But okay, what they mean is that the chicken comes out of an egg and the egg comes out of a chicken. So how did it actually begin? This is a difficult question, don't worry about it, but think about it. It's fun to think about. You could ask yourself though the same question about the rise in CO2 and the rise in temperature. You have seen the graphs that they nearly always increase in the same way and decrease in the same way. Most scientists say that the highest temperatures are a result of increased amount of CO2 in the air. But couldn't it be the other way around? Might it not be the case that the earth just happens to be warming up, and that as a result more CO2 is entering the air? So it's not our fault then, right? If in the past temperature changed first and then CO2 changed, is it possible that temperature was changing again since Industrial Revolution, and hence CO2 started to change, and somehow it just changed more now than before? You have to answer this question because it is a difficult question, and we cannot just say, no, silly, don't ask such questions. Scientists must be able to answer this question. So most scientists say that the higher temperatures are a result of the increased amount of CO2 in the air now, but couldn't it be the other way around like before? Might it not be the case that the earth just happens to be warming, let's say because of orbital changes and sunspots, and that as a result more CO2 is entering the air? So it's not our fault then. But say the power of the sun, the position of the planets, and the currents in the ocean are causing this. But if you zoom in on a graph of CO2 and temperature in the Ice Age, and then you will in fact see that CO2 often lags a little behind the temperature. At the beginning of an Ice Age, you first see the temperature begin to cool down, and then after that the amount of CO2 begins to cool down. Then more cooling happens, more glaciers grow, but the temperature changes because of the position of the earth relative to the sun. When it gets colder, CO2 also disappears from the air, making it even colder, because CO2 is a greenhouse gas. If you reduce it, you allow more heat to go out to space and make it colder. So the amount of CO2 in the air can be both the cause and the consequence of the changing temperatures. Just like a chicken can come out of an egg, and an egg can come out of a chicken. Once the chicken is there, this cycle continues, right? So yes, 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 definitely yes, 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 no, yes, no, yes, nope, nope, no, nah, yes, yes, yes. What is this? In the graphs of the past few centuries, the lines of CO2 and the temperature dance happily around each other, as we saw here. More CO2 causes warming, and the warming causes more CO2. But how do we know for certain that the extra CO2 comes from the chimneys and the exhaust pipes and burning coal and petrol and gas, and not, for example, from the oceans or the volcanoes? Well, there is plenty of evidence, children. In the northern hemisphere, the increase in CO2 is always 2 years behind. Sorry, 2 years ahead. Let me read it again. In the northern hemisphere, the increase in CO2 is always 2 years ahead of the CO2 increase in the southern hemisphere, because there are two hemispheres and the winds don't easily go across and mix everything together. 2 years is exactly the amount of time that CO2 takes to spread out over the planet. So it seems that most of the CO2 is emitted in the northern hemisphere, and that happens to be the half of the earth where most of the people, the factories and the cars are to be found. So it means that we are producing the CO2 and we are causing the warming. So CO2 comes first. This is complicated, don't worry about it. Just think that experts, scientists are doing lots of measurements, lots of experiments in the lab, lot of calculations to tell you that, folks, we are burning fossil fuels and that is increasing CO2, and then the warming is happening. But there's even stronger evidence than just saying this. The CO2 has also sort of a fingerprint. As with oxygen, you have light and heavy sorts of CO2. Plants particularly like the lighter sort, so it is CO2, but C is not always 6 protons and 6 neutrons. Sometimes it has 6 protons and 7 neutrons, and that makes it heavier. And if you're a plant and you're trying to take CO2, why would you bother with the heavier one if it takes more energy to lift it? You will just take the lighter one. That's exactly what happens. Okay, so plants particularly like the lighter sort of CO2, so they absorb lots of light CO2 and more heavy CO2 is left behind in the air. This means that there is naturally a little bit more light CO2 in the plant and a little bit more heavy CO2 in the air. However, since the 18th century, this has been changing, because before that, plants and the atmosphere were talking to each other. Human beings were not doing anything, so plants were happily taking lighter CO2 and leaving behind heavier CO2. Then human beings came along and started digging out old plant material, which is what fossil fuels are, and we started burning them, right? So what happens? This means that there is naturally a little bit more light CO2 in the plants, a little bit more heavy CO2 in the air if we are not doing anything. However, since the 18th century, this has been changing. There's been more and more light CO2 in the air. Where did this come from? This is released when coal, gas and oil are burned because Those fuels are made of plants, and plants had stored lighter CO2. When you burn it, you're releasing the lighter CO2 in the air, so you are increasing the fraction of lighter CO2 in the air when you do this in large quantities. At the same time, there is less and less oxygen in the air, as I said before. Ralph Keeling, the son of Charles Keeling, who started measuring this CO2 in Mauna Loa, is now measuring oxygen and CO2. Very smart guy. So there is less and less oxygen. This is also a big clue, because oxygen is needed to burn coal, gas and oil, and it's not needed for other sources of CO2 such as volcanoes and oceans. If it was coming out of the oceans and volcanoes, oxygen shouldn't be decreasing and the lighter CO2 shouldn't necessarily be increasing. 97% of climate scientists are now convinced that the climate change that is taking place now is caused by human beings. They have other forms of proofs for this, which are even more complicated than what you have just read. Everything indicates that global warming is happening because of the extra CO2 from chimneys, exhaust pipes, but they are not only the factors that are changing the climate. Trees and cows also have a lot of things to answer for. What are they doing? Are they sitting happily grazing and giving us milk and taking up CO2 as trees and not doing anything? So let's see, here is a plant, a nice sunflower with light CO2 in its leaves, because the leaves have stomata that open, take CO2, lighter CO2. And here is a chimney that is burning the plant material. You can see a dead sunflower plant here, which is using up O2 and putting up more light CO2, and the heavy CO2 in the atmosphere is getting diluted because we are burning plant material with light CO2. Lovely, lovely story, right? So we'll come back and talk about how chimneys and cow farts. There is the word again. I'm not sure if your parents want you to use this word, and this podcast is about 17 minutes long. It's a bit long, but it's a nice story. So please enjoy it and come back and talk to me again and listen to me about cow farts and chimneys. Okay, see you in the next podcast, children.